right? Can I get a small confirmation for this, guys, by any one of you? Am I audible? Is my screen visible? And is everything from the internet point of view going really good? Nalandimbi, hi, good evening. Welcome to the session. So, guys, am I audible to all of you? Can I get a small confirmation by any one of you guys? Audible and clear, okay, perfect, very good. Yamini is also confirming, perfect. So, to be honest with you, what is basically going to happen in your batch is that there are certain projects that all of you guys are expected to complete. Right? There is some project work or there are some project works over here that all of you guys are kind of expected to do as the completion of your course curriculum over here. So, what is basically going to happen is that if you are able to see my screen, then you will basically see that these are so this week is basically the last week when we would be interacting with each other, right? uh Today, on Thursday and on Friday, there are three sessions over here with which we are expected to move ahead with. And another thing is that first of all, I am planning to give you an overview, a general overview of the uh, way through which the problem statements are expected to be solved over here, right? So whenever there is a problem statement that is coming over here, then there is a particular what you can say workflow, right? So steps to solve problem, solve projects. And this is a very general workflow that you are expected to move ahead with, right? This is a very, 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 very general workflow. So here are the following steps with which you are expected to move ahead. So here you have importing important libraries. Then you have importing the data, right? Then you have getting an understanding about the data. Then you have getting an understanding about the business problem that you are trying to solve. Next portion over here is uh, detailed EDA, and a detailed EDA is something which is expected to give you the approximate patterns in the data. Based on that approximate patterns, whether it is linear, non-linear, those approximate patterns, right, will kind of help you to get an idea about the shortlist 2 to 3 ML algorithms, 2 to 3 algorithms actually, or methodologies that you are moving ahead. Then you are expected to pre-process the data separately for all the ML algorithms. Pre-process the data for all the ML algorithms over here. Now, after this is done, you perform feature engineering or feature selection, right? Feature engineering and or feature selection. When you are basically gonna do brain test split, then with the help of training data, You train the model, right? And then you present the testing data. You evaluate the predictions of if the evaluation results of the model, right? If the evaluation results of the model are according to your expectations, you know, well, step number 40. Are not uh, not according to your expectations, not you optimize the model. After this is done, the next thing over here is that you deploy the model into production after that. And then you will do uh, maintenance work for the model, right? Then you will basically do the maintenance work for the model. So these basically are some of the portions or some of the sections over here with which you are expected to move ahead with. So take your time, go through this. So I will give you 2 minutes, guys, to kind of move ahead with this particular portion. And once you are comfortable with this section or once you are comfortable with this topic over here, then we will basically kind of move ahead with the other sections over here. So now after this is done, this same ideology is basically something that you guys are expected to apply on the other portions or on the other topics over here, right? So now let us try to move ahead and let me show you the possible portions over here, right? So first of all, today we are gonna deal with what you can say web scraping and machine learning projects. So let me show you a machine learning project over here, right? And like it's a mix of all the portions over here. And let us try to see this. Just 1 minute. Let's see. Computer vision, diabetes detection, right? Let's have a look at this particular problem. So in this particular problem, it's 818. So this is a PDF file, and I think you will get the details about this particular portion from the given part 818. So we are going to basically discuss the data that is available over here, right? So let me extract the data over here. So this is basically the data, and in this particular data, you can see that there is data dictionary. There are so many things over here. So first thing that we have over here is data dictionary. So there are so many portions, right, that can help you to get an idea about a given portion or about a given part. So what happens over here is that it is very important for all of you to understand what these sections or what these portions are all about, right? So what basically is happening over here is that here you are having this particular data, right? So there is variable named encounter ID. So you can basically, whenever you are moving ahead with any project, if you remember, I told you to get an idea about the data with which we are moving ahead, right? Take a minute for this, guys. So now after this is done, the next portion or the next section over here is that it is very important for you to get an idea about the given portion or about the given part over here. So you can see that there are so many input features available over here. Target variable is diabetes mellitus, which is a binary variable, right? So you can see that there are 180 input features, 180. Are you getting my point? 180 input features are there in the data. And they are of mixed types, numerical, categorical, and all of them, right? After this is done, you can basically get an idea, right? After this is done, you can basically get an idea about the training data over here. And what you are expected to do is that on the testing data, you are basically expected to move ahead with the next portion over here. So see, this is the time that it is taking to open up the file, right? So you can get an idea that there are so many features over here, right? And this is the target variable, right? Binary. So this is a binary classification problem. There are a lot of null values that I am able to see in the given data, and you will have to employ some techniques like automated for loops or automated while loops, through which you can, what you can say, replace the missing values with something, right? So first of all, whenever you see the data, it is very important for all of you to get an idea about this section, that how will you basically tackle the individual rows, or how will you tackle the individual portions over here, right? That according to me, that is a very important thing, because you need to plan out the things very well, right? It's very important for all of you guys to plan out the things very well. So now after this is done, whatever categorical columns you guys are seeing, you can one hot encode those categorical columns, right? Whatever numerical columns you are seeing, it depends on which feature you should be writing. Decision tree can be a very good option over here, because with so many input features, linear regression, or sorry, logistic regression can overfit the data. So I personally think that decision tree algorithm with hyperparameter optimization can actually act as a really good option for you guys, right? So ethnicity obviously is something that you can one not encode. In gender column, you can replace the male column with 0 and female column with 1, right? So these basically are some of the sections or some of the things over here that you can kind of see. Similarly, ICU admit, floor number, I mean, you can get an idea about all of these sections over here, right? Now, after this is done, the next section or the next portion over here with which you are working, you can pre-process the data like hospital one hot encoding, ICU admit one hot encoding, ICU type one hot encoding, right? Some columns you can, like the best part about decision tree algorithm is that even if you are feeding the data with collinear features, then that is basically something which is not negatively impacting the predictive performance of them, right? So what you can do is that, like I am just guiding you on the problem statement, right? You will have to do, and you will have to see what exactly you need to do, right? Now, after this is done, The next portion over here is that you can deal with null values. What I'm suggesting is that you separate out the numerical columns, you separate out the categorical columns, right? And then based on that separation, you can basically move ahead with the next part or with the next portion over here, right? So this is one project. You are expected to train the data on the, train the algorithm on the training data, right? After that, what you are basically expected to do over here is that you are basically expected to take the predictions on unseen data. What is the unseen data? Unseen data is this one, unlabeled data. And then you are expected to submit it, right? Then you are expected to submit it on the portal. The access links for the portal and everything is something that you will get from the course coordinators. And then we can kind of try to move ahead, right? Now, after this is done, the next thing that we can kind of try to move ahead with, this is problem number one. This is one of the problems. Now, let us try to have another look at it in which ML needs to be used, or employee turnover prediction, right? This is the project, employee turnover prediction. It's 919. Let me see if I have this particular portion. So, 919, right? So in this, what I'm feeling is that you are expecting the turnover predictions over here, right? So this is the target variable left or right? This is basically the target variable that you are expected to kind of move ahead. So what is basically happening over here? Can you tell me an idea? There is satisfaction level, there is last evaluation, like there are some input features, and based on that, you are expected to predict that whether a particular employee will leave the company or not, right? So this is basically something with which you guys are expected to move ahead, correct? Now, after this is done, let us kind of try to move ahead with the next portion over here. So the target variable with which you are kind of working is, so input features, let's talk about it. The input features that are basically available over here, the input features are basically these many. So satisfaction level, last evaluation, number of project, average monthly hours, time spent at the company, right? Work accident, promotion, sales history, right? And salary bracket. So do you think that these, so obviously these features are basically the features over here that you are expected to move ahead with, right? Correct. Any questions that you guys are having? Everybody have a look at this data, analyze this data, and let me know what you would do with this data. Take 2 minutes for this. Now, after this is done, the next portion over here is that I was expecting some reply from all of you guys, but since nobody gave the reply, let us try to move ahead with the discussion, right? Let me tell you, let me guide you on this. So, what you are basically expected to move ahead with uh, is that this is basically something which needs to be clear with, right? So now what I want is that first column, let us try to decompose the coursework column wise. Satisfaction level. So the satisfaction level, I think, is a numerical feature. You can keep it as it is. Second portion over here, it is basically revolving around last evaluation. Again, a numerical feature. You can keep it as it is, right? Then the number of the project, I think that is the another feature over here. Again, a numerical feature. I think you can keep it as it is, right? So these basically are the sections, or these basically are the portions over here that you can definitely keep as they are, right? Now, after this particular section or after this particular portion is done, the next thing that is there is the average monthly. All the columns, I think you need to keep as it is, apart from sales, which you can one not encode, and salary you can replace low with zero, or low with one, medium with two, and high with three, something like that. And then you can find whether they left or not, right? So it is basically HR attrition project, and attrition basically means that a lot of people are leaving the organization over here, and basically this can also come under the factors affecting attrition, right? So you need to be very clear with this. You need to be aware of this particular section or this particular portion over here. Okay, let's move ahead with the next project now. After that, time series analysis we will do later on. Diabetes prediction, employee turnover prediction. Uh, Next is facial images. No time series, see deep learning. So Instagram data extraction, it is a interesting project that is kind of coming over here, right? It is basically for this section 924. So web extraction is also web data extraction 924. So what is basically going to happen is, let me guide you on this. 924. So in here, what is going to happen is that you are expected to scrape the data, and data scrapping is a very important portion over here. So what is going to happen over here is that you can scrape the data from any portion. There is a reference Jupyter notebook in here, and I think if you get in touch with course coordinators, they will definitely help you on this. So it is your responsibility to kind of get an idea about the given section or given portion over here, right? So what I want you to understand, or what I want all of you to uh, move ahead with over here, is that these things or these sections sometimes play a very pivotal role, and you should be the one who is very clear with it. All right. So choosing the right data set, you can take the data from these sources. So you can take the data from Kaggle, point number one. You can take the data from UCI's machine learning web repository, and you can also take the data from Google data search engine. So you can basically take any live URL, and you can do the web scraping of that of the data from that URL with the help of beautiful soup, with the help of Selenium. right? Whatever you want to move ahead with. We have completed beautiful soup. If you paid attention in the live coding session, then we have basically used beautiful soup for SpaceX library, right? So we took the data from the online web page of SpaceX, and I think that is definitely something which you should pay attention to, right? Now, after this particular portion is done, the next thing over here with which you guys are kind of expected to move ahead with, it's revolving around some interesting sections over here, right? So I think that is completed. What's the next project? Social media and name detection, MNS, digit classification, regression, profit prediction. Okay, this looks like a pretty simple and pretty decent one. 906. So in 906, what happens is that there is like the data for multiple companies over here, and you are expected to predict this given portion. So based on the amount of money that the company is spending on R&D, administration, marketing, and the state, you are expected to predict profit. And I think this should be a very simple cakewalk for all of you guys. It is a simple regression model, or it is a simple regression coursework, right? So the target variable is profit, and there is just one feature that you have to deal with, and that one feature is state. I think you can one hot encode the state column and you can try to move ahead with it. Right, so you take 2-3 minutes for this, analyze the data and let me know what you will do with this. Right, take 2 minutes for this. So basically I'm getting one comment over here. I can share the project's Excel file, right? Definitely I can share it. And so what will you do with the data set that is given to you? What will you do with all the columns? What is the approach that you would be using? So basically what you need to do is that, as I was telling you, that the three input features with which you are working, it's already pretty sorted. So R&D spend, administration, marketing spend, state, right? According to me, these features are already pretty much sorted. You don't need to uh, do a lot on the data that is available over here. What you need to basically actually do or actually complete over here is that you need to get an idea about the given sections or about the given portions over here, right? So you actually need to be very clear that only the state column is categorical, and if you deal with the state column properly, then uh, it will not lead to a lot of problems later on. So technically, it's just the state column that you have to one-hot encode. You can separate the input features, right, and the target variable profit, and it, based on that, you can try to fit linear regression, decision tree regressor. There are multiple models over here. Right, so it basically depends on the fact that which predictions or which models over here are something which are depicting the trend or which are depicting the pattern, right? So take your time and do let me know about this particular portion. After this is done, the next coursework or the next project that we are having, it is just 1 minute where it was rain prediction. You are predicting whether the rain would come or not, and it's 828, right? So in 828, let me extract all. And now what is going to happen over here is that let's try to see the data over here. So this is the rainfall prediction problem, and I personally think that this is also a really interesting project work to kind of move ahead with. So what is going to happen over here is that first column is the date column, and whenever you see a date column over here, always try to take this into consideration, that can we apply a time series portion in that data, right? So obviously rain prediction is dependent on seasonal, so seasonality trend, right? These are some of the things over here that you are expected to move ahead with. So location, the date, maybe you can take the month out of that date, and I use that as an input feature because there are some months when there is rain, right? So I personally think that month can be used as a really interesting input feature over here, and then you can kind of try to move ahead with the later sections or later portion, right? Apart from this particular portion, right, the next thing that I want all of you to basically take into consideration over here, it revolves around some topics or some logics. So the target variable right in here is that rain today, right? That's the target variable. You are expected to predict where there is rain today or not. So you can, I mean, there are a lot of features. There are null values in some features. I mean, it totally depends on you how you are kind of planning to move ahead, right? So this is basically something that I can keep it all up to you, right? Now, after this particular section or after this particular portion is done, the next thing that I can definitely try to help you with, right? Let's see, rain prediction, computer vision, wine quality. Yes, accessing the quality of the wine, 870. So let us try to move ahead with this 870. So wine quality, no, it's 825. So wine quality is something that is definitely gonna be a really important section or a really important portion over here. So this is the text document which can give you information about the citations and everything. So what are the input features and everything? And I have worked with this data. I have created the predictive algorithms on this data. There are two qualities of wine, red and white, by the way. So there is fixed acidity, there is volatile acidity, there is citric acidity, there is residual sugar, chlorides. I mean, all of these are the input features over here, and you are expected to predict this part quality. So quality is something which is on a range of 0 to 10, and you are expected to predict it. It is a regression problem. So you are expected to identify that which are the input features over here that you move ahead with. So take your time, observe this, right? And let me know if I can help you with anything over here. Then I will discuss some really important, well, like when I moved ahead with this problem statement, there are some interesting things that I have to discuss with you. Take 2 minutes first, you go through this data. Now, after this is done, let me tell you that when I worked on this particular project, you can see that majority of the features are numerical. So you don't need to do one-hot encoding. That's the first point. And second point over here is that you can create some features. Like what I did is that I created just one feature called as acidity, which was the or total acids, which was the sum of fixed acidity, volatile acidity, and citric acid. Right? That was the first thing that I did. And I created the total sulfur dioxide content, which was the sum of free sulfur dioxide and total sulfur dioxide. So in this way, I tried to create some interesting features and I tried with the modeling process over here. And the same goes for all of you guys, right? So this is something that you guys are expected to be completely clear with. So this is a regression problem. You can use linear regression, you can use decision tree regressor, and to be honest with you, getting a good performance in classification algorithms is very simple. But getting a good performance in regression algorithm is basically something that requires efforts, right? That is not simple. So if you are being given a regression problem, mark my words, regression problems are tougher than classification problems to get good performance, right? So that is definitely something that we can consider over here. Now, after this is done, right? After you are clear with this, after this one portion is done, the next section that I want you guys to kind of understand over here, it is basically revolving around this topic. So let's close this data, right? And let's see what is the next project. So wine quality is the first in natural language processing center. Shop sales prediction, right? So what is it? It is 849. So definitely we can consider 849. 849. Okay, it takes the data from Kaggle, I think. Sign language store sales projection. This is 1095. 1094. I think it is taking the data. TED Talk analysis. Right, try to have a look like which problem we can kind of discuss over here. So basically video analysis, I think this is something weighted tips analysis. Yes, this is something that we can do 934. 934, yes. So weighted tips analysis is something that we can kind of try to do over here. So this is, by the way, a really famous inbuilt data set in what you can say Seaborn library. It is called as tips data set. So depending on the total bill, the gender of the waiter, whether the person who gave the bill, whether that person was smoker or not, uh, the time of the day, the time and the size, you are expected to predict the tip. And I have worked on this data set. The tip variable shows a very strong correlation with total bill. So basically, what is happening over here is that you can easily create a regression model over here. The target variable is continuous, but you can take 3-4 minutes, take your time, and try to analyze what you can do on this data. Take your time for this. So basically, you can take a minute of your time and get an idea that what exactly needs to be done on this particular portion over here. So basically, what is happening over here is that these particular sections or these particular portions need to be very clear. Let's see web scraping portion 928 about Rotten Tomatoes. So 928, I think in here you will have to gather the data from the online source, right? So what is basically happening over here is that let me see if there is some other project. Game sales prediction. I think yeah, this can work out. 842, 842, yes. So this is basically the data. And over here, you are expected to predict the global sales, right? So rank uh, the name of that game, the platform, the year, the genre, the publisher, and then the global sales, right? Which is, I think, the sum of these given portions. So that's the problem statement over here, right? So the detailed problem statement, this is the data. You can have a minute of your time to go through this, and then we can move ahead with the next section. Now, after that, let me see if we have anything else over here. extracting, so that project we will cover tomorrow, right? So Murtaza, tomorrow you can see that there is ANN deep learning, object detection, so that we will cover on Thursday, and NLP and time series projects we will cover on Friday. So it is decomposed day wise, right? So day wise we will try to cover it up, don't worry on that. So clustering is present, analyzing the uh, travel insurance prediction, and it is 847. Let's try to get an idea about 847 travel insurance prediction. So this again seems like a really interesting problem. Depending on the age, depending on the employment, depending on whether that person is graduate or not, annual income, family members, chronic diseases, frequent trial, ever traveled or not, right, abroad, you are expected to find if that person will take travel insurance or not. And I think this is a really interesting problem over here with which you can work with. All right. So this is definitely something that can really help you in a lot of sections or a lot of portions. So don't worry on this. So this is a binary classification problem. Last one that we are going to discuss today, the employment type column, is something that you can one hot and code. In frequent flyer, you can replace yes with one, no with zero. And in ever traveled abroad, you can replace yes with one, no with zero, right? So these are some of the sections over here that you can kind of try to implement, right? Perfect. Then I think we are in a really comfortable, we are in a really good to go position, right? That today's discussion about the project works is completed. And let us do one thing, that let's have the poll questions now. You can complete the poll questions and then we will have a discussion about it after 10 minutes, right?